August 7, 1944. Mortagne, Normandy. 06:15 hours. The distinctive metallic crack of a high-velocity armor-piercing round, tearing through steel, echoed across the Normandy hedgerows, a sound so sharp and violent it seemed to split the morning air itself. Oberleutnant Hans Müller, commander of a Panther OSV in the 2nd SS Panzer Division, had perhaps 3 seconds between hearing that sound and understanding its meaning. 3 seconds during which his brain processed the impossible information that his tank, protected by sloped frontal armor that had deflected British 75mm rounds and American 75mm Sherman fire throughout the past month of fighting, had just been penetrated by a shell that possessed velocity and kinetic energy his training had taught him only the heaviest Allied anti-tank guns could generate. The HVAP round, hypervelocity armor-piercing, a tungsten cord projectile fired from an American 76mm gun mounted on what appeared to be just another Sherman medium tank, struck the Panther's glacis plate at an angle that should have resulted in deflection, but instead punched through 80mm of face-hardened steel as if it were ordinary plate, the round's depleted core maintaining coherence through impact and sending a cone of superheated metal fragments through the fighting compartment in a microsecond of catastrophic energy release. Müller never heard the secondary explosion that followed when those fragments ignited ammunition stored in the Panther's hull, never felt the overpressure that killed him and his crew instantly, never experienced the confused final moment when his understanding of armored warfare, built on 2 years of Eastern Front experience where German tank superiority was axiomatic, collided with the material reality that American industrial capacity had produced a projectile that negated the technological advantages German armor had possessed. The sound of that HVAP impact, replicated across dozens of similar engagements during the Mortagne counteroffensive and in subsequent battles through the Lorraine campaign and into the Ardennes, became the acoustic signature of a technological surprise that challenged German assumptions about American military capability and about the nature of the armored warfare that had seemed to favor German designs and tactics throughout the war's middle years. For the American tank crew that fired that killing shot, a 76mm Sherman from the 2nd Armored Division's Company B, 67th Armored Regiment, the engagement represented vindication of technologies and tactics that had been controversial within American armored forces, and that reflected broader debates about how to counter German heavy armor. The tungsten carbide penetrator at the heart of the HVAP round was a metallurgical achievement that required industrial processes and material resources Germany could not match, a projectile whose development represented American institutional capacity to identify technical problems, mobilize scientific expertise, translate research into production at industrial scale, and distribute the results to combat units with speed that German bureaucracy and resource constraints prevented from matching. Each HVAP round was expensive, consumed strategic materials that had competing uses, and represented industrial investment that only societies with surplus productive capacity could afford to make in quantities sufficient for operational impact. This moment, a German tank commander dying before comprehending what weapon had killed him, an American tank crew discovering they possessed capability to defeat German armor that had previously seemed invulnerable, exemplified the technological and industrial asymmetries that increasingly characterized the war's final year. For German soldiers who had fought with confidence in their equipment's superiority, who had relied on Panther and Tiger tanks to provide qualitative advantages that compensated for growing numerical disadvantages, the appearance of American tank guns that could penetrate German armor at combat ranges fundamentally altered tactical calculations and psychological certainties that had shaped armored warfare since Germany's initial successes in 1939 to 1940. To understand the significance of HVAP ammunition and the shock its use produced among German armored forces, one must first comprehend the evolution of tank versus tank combat and the technical arms race that characterized armored warfare throughout World War II. The fundamental challenge of tank combat was penetrating increasingly thick armor at increasingly long ranges, while maintaining mobility and operational reliability. This drove a cycle of escalation, where thicker armor demanded more powerful guns, which required larger turrets and stronger chassis, which reduced mobility and reliability, which could be countered with better armor placement and metallurgy, which again demanded more powerful guns. German tank development had followed this cycle aggressively, producing by 1943-44 designs like the Panther and Tiger that emphasized heavy armor and powerful guns at the expense of mechanical complexity and resource consumption. The Panther, introduced after German encounters with Soviet T-34 tanks, demonstrated the inadequacy of earlier designs, mounted an excellent 75mm Kbboy K42 L70 gun, and featured well-sloped frontal armor that provided effective protection equivalent to much greater thickness. The Tiger, though produced in smaller numbers, mounted the legendary 88mm KWK-36 gun that could destroy any Allied tank at ranges where Allied guns could not effectively respond. These tanks represented German engineering excellence and tactical doctrine emphasizing quality over quantity, assuming that superior individual tank designs could compensate for the numerical superiority Allied production would inevitably achieve. American tank development had followed different paths shaped by different institutional priorities and industrial realities. The M4 Sherman medium tank, which became the standard American tank through most of the war, emphasized reliability, ease of production, and operational sustainability rather than maximizing armor or firepower. The Sherman was designed to be produced in enormous quantities. Nearly 50,000 were manufactured during the war, using automotive industry production techniques and with components that could be manufactured by firms with no prior tank building experience. The Sherman prioritized mechanical reliability, ease of maintenance, and crew ergonomics, reflecting American doctrine that emphasized keeping tanks operational and crews alive rather than achieving marginal performance advantages through mechanical complexity. But the Sherman's initial armament, a 75mm M3 gun, was increasingly inadequate against German heavy armor by 1944. The 75mm could defeat most German medium tanks at typical combat ranges, but struggled against Panthers and was essentially ineffective against Tigers except at point-blank range or through flank shots. American tank crews in Normandy discovered that engaging German heavy tanks was suicidal unless they could achieve ambush positions or overwhelming numerical superiority, neither of which was consistently achievable given German defensive advantages in terrain and tactical deployment. The resulting armor disparity created morale problems and tactical constraints that American commanders recognized required technical solutions. The introduction of the 76mm gun on Sherman variants beginning in 1944 was the first American response. The 76mm M1 gun provided improved armor penetration through higher muzzle velocity and better ammunition, though even standard 76mm armor-piercing rounds remained marginal against Panther frontal armor at combat ranges. What transformed the 76mm Sherman from a modestly improved tank into a legitimate threat to German heavy armor was the development and deployment of HVAP ammunition, a specialized projectile that achieved armor penetration through fundamentally different physical principles than conventional armor-piercing rounds. Traditional armor-piercing ammunition relied on a solid steel projectile with hardened tip, penetrating armor through kinetic energy and material hardness. The projectile's ability to penetrate depended on its velocity, mass, and the quality of steel used in its construction. These rounds were limited by the mechanical properties of steel itself. There were practical limits to how hard the steel could be made before becoming brittle, limits to how much velocity could be achieved before barrel wear became prohibitive, and limits to how much mass could be accelerated to useful velocities by propellant charges that guns could withstand. HVAP rounds overcame these limitations through a composite design that used a tungsten carbide core, surrounded by a lighter aluminum sabot. Tungsten carbide possessed density and hardness far exceeding steel, meaning a smaller, lighter projectile could achieve higher velocities while retaining superior penetration characteristics. The aluminum sabot provided gas seal in the gun barrel during firing, allowing the smaller tungsten core to utilize the full propellant charge, then separated from the core after leaving the barrel, leaving the dense tungsten penetrator to continue toward the target at velocities exceeding 3,000 feet per second, substantially higher than conventional armor-piercing rounds achieved. The physics of armor penetration at these velocities became almost hydrodynamic, rather than purely mechanical. The tungsten penetrator possessed kinetic energy density so high that upon impact with armor plate, both the penetrator and the armor behaved almost like fluids for the microseconds during penetration, with the tungsten's superior density allowing it to punch through steel that would have deflected conventional projectiles. The result was armor penetration capability that exceeded what the 76mm gun's caliber would suggest was possible, with HVAP rounds achieving penetration performance comparable to much larger guns when firing conventional ammunition. The development of HVAP ammunition required American industrial and scientific capabilities that Germany could not match by 1944. Tungsten was a strategic material with limited global availability, used in machine tools, armor-piercing ammunition, and various industrial applications. The United States controlled or had access to tungsten sources that Germany lacked, and American industrial capacity could allocate tungsten to ammunition production in quantities that German resource constraints made impossible. The metallurgical expertise required to manufacture tungsten carbide cores with appropriate density and structural properties resided in American research institutions and industrial laboratories that maintained close relationships with military development programs, enabling rapid translation of laboratory concepts into production specifications. The production of HVAP rounds at scale required industrial processes that few nations possessed. Tungsten carbide is difficult to manufacture, requiring high-temperature sintering processes and precise quality control to ensure consistent material properties. The aluminum sabots required precision machining to ensure proper fit and separation characteristics. The complete rounds required assembly procedures that maintained tolerances ensuring accurate flight characteristics. American industry accomplished this production despite the complexity and despite competing demands for tungsten in other applications, producing HVAP rounds in quantities sufficient that they could be issued to tank units for routine combat use rather than being reserved for rare special circumstances. German intelligence became aware of HVAP ammunition's existence through various channels: technical intelligence, from captured American equipment, interrogation of prisoners, and direct battlefield experience when German tanks began being penetrated by weapons that should not have been capable of such penetration. But German understanding remained incomplete, in part because American security classifications restricted distribution of HVAP rounds, and in part because German metallurgists and ordnance experts struggled to believe that Americans had achieved the manufacturing sophistication and resource allocation that HVAP production required. German intelligence assessments often underestimated American technical capabilities, assuming that American industrial strength lay in mass production of adequate equipment rather than in the ability to produce sophisticated specialized weaponry that matched or exceeded German equivalents. The tactical impact of HVAP ammunition extended beyond its immediate armor penetration capabilities to affect the psychological and tactical dynamics of armored combat. German tank crews who had operated with confidence that their frontal armor provided effective protection against most Allied tank guns suddenly faced threats from weapons they had previously dismissed. The 76mm Sherman, which German crews had learned to engage with relative confidence, became a lethal opponent that required the same respect and caution that German crews previously reserved for encountering specialized tank destroyers or anti-tank guns. This psychological shift was as significant as the technical change. German armor tactics that relied on frontal engagements and superior armor protection had to be revised. When facing opponents whose weapons could penetrate German armor at ranges where German guns could kill American tanks, the Battle of Mortain in August 1944, where the opening scene's engagement occurred, illustrated both the tactical effectiveness and the limitations of HVAP ammunition in actual combat conditions. The German counteroffensive at Mortain aimed to cut off American forces that had broken out from the Normandy beachhead, using concentrated armor to drive to the coast and split Allied forces. The operation committed substantial Panzer and SS Panzer divisions, including Panthers and Tigers that German commanders expected would achieve tactical success through superior armor and firepower despite Allied numerical advantages. American defensive forces at Mortain included 76mm Shermans equipped with HVAP ammunition, deployed in defensive positions that provided advantageous firing positions. and that could engage German armor at medium ranges, rather than at the extended ranges where German guns' superior ballistics provided greater advantages. The engagement saw multiple instances of 76mm Shermans successfully penetrating Panther frontal armor with HVAP rounds, achieving kills that would have been impossible with standard ammunition, and that surprised both American and German participants. German after-action reports noted with alarm that American medium tanks had demonstrated unexpected capability against German heavy armor, representing a development that required tactical adjustments and that suggested American technical capabilities had been underestimated. However, HVAP ammunition was not a panacea that instantly equalized tank combat. The rounds were expensive and in limited supply, issued to tank crews with instructions to reserve them for engaging heavy German armor, rather than using them against lighter targets that standard ammunition could handle. This created tactical complexity where tank commanders needed to identify targets accurately under combat conditions and make rapid decisions about which ammunition to use, decisions complicated by the stress of combat and by the difficulty of distinguishing Panther and Tiger tanks from lighter German armor at the ranges where engagement often occurred. The ammunition's scarcity also meant that American tanks could not rely on HVAP availability for all engagements, forcing continued dependence on tactics that minimized exposure to German guns and that sought advantageous positions where flanking shots or close-range engagements became possible. American tank crews developed sophisticated tactical approaches that combined maneuver, suppressive fire, and coordinated attacks to defeat German armor, recognizing that even with HVAP ammunition, frontal duels with German heavy tanks remained dangerous and best avoided when alternatives existed. The sound of HVAP impacts, that distinctive sharp crack, followed by secondary explosions when the hypervelocity projectiles, penetration ignited ammunition or fuel, became a recognizable signature in American tank units, a sound that represented both technological achievement and tactical validation. Unlike the relatively duller reports of conventional armor-piercing rounds impacting armor, HVAP rounds produced acoustic signatures that reflected their extreme velocities and penetration energies, sounds that veteran tankers learned to associate with successful armor, penetration, and enemy tank destruction. This sound became symbolic of American industrial capacity and technological sophistication applied to tactical problems. Each HVAP round represented tungsten extracted from ore, processed through complex metallurgical procedures, manufactured into precision projectiles, transported across oceans to European battlefields, and delivered to tank crews who could employ them confident that American industry would continue producing ammunition in quantities sufficient to sustain combat operations. The sound announced that American forces possessed not just numerical superiority, but increasingly sophisticated weapons that could challenge German technical advantages, that the qualitative gap that had favored German armor was closing through American application of industrial resources and scientific expertise to military problems. At German responses to HVAP-armed American tanks revealed the constraints that increasingly bound German military capabilities. By late 1944, German armor designers could have developed equivalent hypervelocity ammunition. German metallurgical expertise was excellent, and German understanding of armor penetration physics was sophisticated, but resource constraints and industrial disruption prevented translation of technical knowledge into operational capability. Tungsten was scarce in Germany, with limited domestic production and external sources increasingly interdicted by Allied military success. German ammunition production struggled to maintain output of conventional rounds, leaving no capacity to develop and produce specialized projectiles in quantities that would provide operational impact. German tactical responses emphasized methods that didn't require industrial solutions, improved deployment of armor in defensive positions that minimized exposure, increased reliance on anti-tank guns and infantry anti-tank weapons to supplement tank capabilities, and doctrinal adjustments that recognized German armor could no longer assume qualitative superiority that compensated for numerical disadvantage. These tactical adaptations were partially effective, but could not fundamentally alter strategic realities that Germany faced by late 1944, where Allied numerical superiority in tanks, in tactical aircraft, in artillery, and increasingly in tank ammunition Quality created combined pressures that German forces could contest locally but could not overcome. Operationally, the broader strategic context of American armor operations in 1944-45 placed HVAP ammunition within larger patterns of American military effectiveness that combined adequate equipment with overwhelming resources and systematic institutional competence. American armor forces were not individually superior to German equivalents in most technical parameters. German tanks generally had better guns and armor. German tank crews often had superior training and experience. German tactical doctrine emphasized combined arms coordination that was theoretically sophisticated, but American forces possessed advantages that proved more operationally significant. Mechanical reliability that kept higher percentages of tanks operational. Logistics networks that sustained combat operations despite extended supply lines. Replacements that maintained unit strength despite casualties. And increasingly ammunition that negated German technical advantages through application of industrial resources and scientific expertise. The Sherman tank, equipped with a 76mm gun and supplied with HVAP ammunition, represented the maturation of American armored capabilities, combining adequate platform performance with specialized ammunition that provided capability to engage German heavy armor on more equal terms. This combination was not optimal. American armor doctrine would evolve in subsequent decades to emphasize more heavily armed and armored tanks, but it was sufficient for the tactical and operational situations American forces faced in 1944-45, and it was achievable within the production and logistics frameworks that American industry and military institutions had developed. The psychological impact on German armored forces of encountering HVAP-armed Shermans extended beyond individual tactical engagements to influence broader German perceptions of American military capability. German propaganda and military culture had consistently emphasized German technical and tactical superiority, portraying Allied victories as resulting from numerical superiority and material advantages that German skill and courage could contest, despite unfavorable odds. The appearance of American weapons that could match or exceed German equivalents challenged these narratives, suggesting that American industrial strength translated not just into quantity, but into quality, that American technical and scientific capabilities were more sophisticated than German assumptions had recognized, and that the material balance of the war favored the Allies in dimensions that tactical excellence could not overcome. For individual German tank crews, the knowledge that American medium tanks could destroy Panthers frontally, with specialized ammunition, created tactical dilemmas that eroded confidence and constrained options. The tactical freedom that superior armor protection had provided, the ability to engage American tanks confidently, to maneuver aggressively knowing that frontal armor would protect against most threats, was compromised by uncertainty about whether enemy tanks were carrying HVAP rounds. This uncertainty forced more cautious tactics, more emphasis on defensive positioning and on avoiding exposure, more psychological stress from knowing that any engagement could prove fatal, regardless of how well the crew executed tactically. The American tank crews, who received and employed HVAP ammunition, experienced their own transformation in confidence and tactical approach. Crews who had entered combat knowing their Shermans were outmatched by German heavy armor, who had developed tactics based on avoiding frontal engagements and seeking flanking opportunities, discovered that HVAP rounds provided capability to engage Panthers and Tigers more directly. This didn't eliminate the advantages of tactical positioning and combined arms coordination, but it reduced the psychological burden of knowing that head-to-head engagements were suicidal, that crews could fight German heavy armor when circumstances required without accepting certain death. The technical specifications of HVAP ammunition reflected American approaches to military problems that emphasized applying industrial and scientific resources to achieve tactical effects. The M93 HVAP round for the 76mm gun weighed approximately 9.4 pounds complete, with a tungsten carbide core of approximately 4 pounds. The round achieved muzzle velocities approaching 3,400 feet per second, substantially higher than the roughly 2,600 feet per second achieved by conventional M62 armor-piercing rounds. This velocity increase translated directly into armor penetration improvement, HVAP rounds could penetrate approximately 150 meters of face-hardened armor at 500 yards at 30 degrees obliquity, compared to roughly 100 meters for conventional AP rounds, a 50% improvement that made the difference between deflection and penetration against Panther frontal armor. The production statistics for HVAP ammunition remained classified during and after the war, but available evidence suggests that production was measured in hundreds of thousands of rounds rather than millions, reflecting both the expense of manufacture and the limited tungsten availability. This scale was sufficient to provide operational impact, enough rounds that tank crews could expect to have HVAP available for critical engagements, but not enough that HVAP could replace conventional ammunition for routine use. The allocation prioritized distribution to units most likely to encounter German heavy armor, with frontline combat units receiving priority over reserve or training formations. The logistics of distributing HVAP ammunition to frontline tank units demonstrated American institutional capabilities in managing complex supply chains across extended distances. HVAP rounds manufactured in American plants were packaged for transport, shipped across the Atlantic in convoy vessels that had to survive submarine threats, unloaded at European ports, moved through logistics networks that brought them to field ammunition dumps, and finally delivered to individual tank units that requested specialized ammunition through normal supply channels. This process required coordination across multiple organizations, systematic tracking of specialized munitions to ensure they reached units that needed them, and maintenance of security classifications that prevented the specialized ammunition from being identified and targeted by German intelligence. The German discovery of HVAP ammunition through battlefield recovery of fired projectiles and through technical intelligence analysis of American ammunition supplies captured during the Battle of the Bulge provided German metallurgists with physical examples to study. German technical analysis correctly identified the tungsten carbide core and understood the physical principles that provided improved armor penetration, but this knowledge could not be translated into German production of equivalent ammunition in quantities that would matter operationally. German tungsten supplies were inadequate. German ammunition production was stretched, meeting demands for conventional munitions, and by late 1944, Allied bombing of German industry created disruptions that made development of new production capabilities essentially impossible. Regardless of technical feasibility, the sound of HVAP rounds impacting and penetrating German armor, that sharp, distinctive crack that differed from conventional, armor-piercing impacts echoed through the final months of the war in Europe as American armored forces pressed into Germany itself. The acoustic signature became associated with American armored effectiveness, with the technological surprise that challenged German assumptions about American capabilities, and with the broader reality that material balance had shifted decisively in favor of the Allies through combination of numerical superiority and increasingly sophisticated weapons that could challenge German technical advantages. In the post-war analysis of armored warfare and tank development, HVAP ammunition represented an evolutionary step toward the fin-stabilized armor-piercing discarding sabot rounds that would become standard in subsequent decades. The concept of using a sub-caliber dense penetrator to achieve superior armor penetration at high velocity would be refined through better projectile designs, improved propellants, and more sophisticated materials, but the fundamental principles demonstrated by HVAP remained valid. American investment in this technology during World War II, despite its expense and complexity, provided experience and institutional knowledge that informed post-war development and maintained American competitiveness in the technological arms race that characterized Cold War armor development for the German tank crews who encountered HVAP-armed American tanks in combat. The experience represented the culmination of trends that had been developing throughout 1944. The erosion of German material advantages, the increasing effectiveness of Allied weapons and tactics, and the recognition that Germany faced opponents whose industrial and technological capabilities exceeded what propaganda and initial war experiences had suggested. The shock of having Panthers penetrated by Sherman guns was not just tactical, but psychological and ideological, challenging narratives about German superiority and forcing recognition that the war was lost not through failure of will or courage, but through material realities that tactical excellence could not overcome. The American tank crews who fired those HVAP rounds and achieved kills against German heavy armor experienced validation of American approaches to warfare, the emphasis on adequate rather than optimal equipment, the reliance on industrial capacity to provide specialized capabilities when needed, the systematic institutional competence that could identify technical problems and mobilize resources to solve them at scales that influenced operational outcomes. Each successful HVAP engagement was a small vindication of American military philosophy, demonstrating that industrial democracies could compete effectively in technical sophistication while maintaining advantages in production scale and resource availability. The sharp crack of HVAP rounds penetrating Panther armor was ultimately the sound of industrial warfare reaching maturity, of technological competition producing weapons of such sophistication that raw courage and tactical skill could not overcome material and technical advantages, of American capacity to apply scientific knowledge and industrial resources to military problems producing results that changed tactical calculations and challenged enemy assumptions. The sound announced that American forces possessed not just overwhelming numbers, but increasingly effective weapons, that the qualitative advantages German forces had relied upon were eroding, and that the future belonged to nations that could mobilize industrial and scientific resources at scales that sustained both quantitative and qualitative advantages across sustained campaigns. When Germans encountered America's 76mm Shermans armed with HVAP rounds shredding Panthers, they confronted evidence of American capabilities that propaganda had insisted could not exist, faced tactical realities that challenged doctrines built on assumptions of German technical superiority, and experienced directly the material manifestation of industrial and scientific advantages that would prove decisive in determining the war's outcome. The tungsten penetrators punching through face-hardened steel carried messages beyond their immediate destructive effects. They announced that American industrial democracy could compete at the technological frontier while maintaining overwhelming advantages in production scale, that material abundance enabled both quantity and quality, and that the acoustic signature of armor penetration was ultimately the sound of freedom and abundance translated into military effectiveness, that totalitarian alternatives could recognize but could no longer contest successfully.